So, now continuing with the discussion about the utility where a person can be analyzed as a risk averse person, risk seeker person and risk indifferent person, and based on that how we basically analyze the problem in the case of marginal rates, and what are the, that is basically the first derivative, and what are the second derivatives, how can be utilized with respect to a utility function, also with respect to a decisions perspective, also as well as with respect to the case when we generally analyze the optimization problem. We will consider these very simple cases. Consider I1 and I2 are the investment. In a very general sense, they are money. It is basically in Indian rupees, in dollars, whatever it is. And a risk averse person would be one where he or she would basically be trying to take the decision where the probabilistic outcome is not the case. So, if you see the first equation and see the right hand side, what you have is basically the case where the probability is 1. So, given that case, the person always thinks that the overall outcome is always fixed, there is no uncertainty in that. So, he or she would be tempted to take that one. If you consider the second case, which is a risk neutral person, he or she basically trying to analyze the situation, trying to see what is the average outcome of that. So, if you see the expected values on both the sides, if they are equal, obviously he or she takes that decision into consideration, where both the outcomes are of same expected value. And if we consider a risk seeker, the risk seeker is not seeing the overall outcome on a general sense. He or she is basically checking that given the choices, if the risk case which has some probability, which in the initial case we saw probabilities being half and half, if there is a probability of P1 and P2, whatever it is, if the value is coming out to be higher, then the person is always having a look at that value such that the overall outcome in general sense is always positive to him or her. So, obviously that person would basically be a risk seeker. But having said that, it should be remembered that a human being or a person risk attitude changes based on his or her income, based on different type of situation, based on his or her age. We will consider only the wealth perspective in our problems. Hence, the concept of risk changing depending on the attitude would only be dictated by the prices of the stock as well as the total amount of wealth a person has in order to invest. Now, consider that how a person can be analyzed as a risk seeker, risk neutral and risk averse person. So, mathematically you will basically have two concepts. One is which we mentioned is basically the first derivative, that is more you want, more is given to you, and obviously you are non-satiated, that means you would like to have more and more. And the second one would basically be the second derivative of the utility function, which we will consider later on as using some concept of absolute utility and relative utility. We will see that later on, where absolute utility would be given by the symbol of AW and relative utility will be given by the symbol of RW. Like utility is UW, so correspondingly you have A and W and RW for the absolute case and the relative case. So, if you see a person without going to the theoretical proofs, you will see the risk averse, risk neutral and risk seeker person can be analyzed depending on the second derivative of the utility function accordingly. And how they are utilized, I am going to come to that later on. So, if you see the curves, the green one is where as for both all the three cases as wealth increases, the utility value also increases. But if you see it carefully for the green, the blue and the red, the rate of change of the function which is UW divided by W is different for the different cases. See in the green one it increases, but increases at a decreasing rate. For the blue one it increases and increasing at a constant rate. For the red one it increases, but increasing at an increasing rate. So, obviously that would basically be able to characterize the person accordingly, whether risk seeker, risk neutral or risk hater person, or who does not like the risk. So, if you consider the marginal rate function looks like an concave curve for the risk averse person. Similarly, for the person who is risk neutral, it will be a not a concave or a convex curve, which is basically the straight line, which is the blue one. And the marginal rate looks like a convex curve is basically a risk seeker person. That means as the wealth increases, the overall risk perspective also changes accordingly on the positive direction. Now, if we see the marginal rates is if you see the curves which I mentioned for the risk averse, the marginal rates is increasing and decreasing rate. marginal rates is increasing at a constant rate. For the middle person who is not a risk seeker, not a risk hater, indifferent person, and for third case is marginal rates is increasing at an increasing rate for a risk seeker. So this is, as you see, the dy dx or du dw changes its slope. So that means it basically becoming more and more towards 0, becoming almost horizontal to the x axis, which is w. If you see the risk neutral person, again it's constant, and if you see a risk seeker person, it's increasing at an increasing rate. So that means it basically becomes 90 degrees dy dx function, which is basically du dw. Now, few other important concepts which will be utilized later on also would be a risk averse person rejects a gamble. Gamble means basically an outcome which is two probabilistic trees or arms. So implication is the double derivative is less than 0. For a risk neutral person, double derivative is 0, and for a risk seeking person, double derivative is greater than 0. That means a person rejects a fair gamble, is indifferent between a fair gamble, and the other third case is risk seeking is basically select a fair gamble. Now there are two terms which we will consider is, as I mentioned, is the absolute risk aversion and the relative risk aversion. So without going to the proofs, I just state the formulas as it is. So AW would be the ratios or double derivative of UW divided by UW's first derivatives, and how it is implication we will come to that later on. So for the three different types of person, if the first derivative of AW, that means the equation which you have is minus of that the ratios, if you take the derivative of that and the values are less than 0, equal to 0 and greater than 0, the person can be clubbed as risk aversion, risk constant risk, that means indifferent, and the third case would be basically a person who has an absolute risk aversion which is increasing on the general trend. So now if you have a bar which is first derivative and all the derivatives would be taken with respect to w. So if a dash or a bar is basically less than 0, which you see the last column is equal to 0 and is basically greater than 0, then obviously it will mean on the absolute sense, as wealth increases, the amount of held in the risky assets which are stocks is basically increasing. For the person whose absolute risk aversion is decreasing. Similarly, for the other two persons, it will basically be equal to 0 and greater than 0 would basically quantify that person as constant absolute risk aversion and increasing risk aversion. Now, another property which will also be relevant is the relative risk aversion. So, if you see the relative risk aversion, it is basically minus W into the terms where the ratios are exactly equal to the AW part. So, what you are doing is that you are multiplying the AW with the value of W. So, if you take again the derivative of RW with respect to W, which is where W is basically wealth. So, again you can analyze the person as in having risk aversion property where R bar or R dash is less than 0, then if it is equal to 0 and greater than 0, obviously you have constant, and another is increasing relative risk aversion properties. So, on the percentage of wealth, this is just a different characteristics how you analyze the person. If the wealth percentage increases, held in the risky asset increases. If it is basically decreasing or is constant, again you can basically analyze a human being or an investor in the three different categories which we have already discussed. Now, in general sense, we will consider utility function having different characteristics. So, a utility function in general, if you see any economic literature or some you analyze different type of economic decisions, it would basically a quadratic one. And why I am mentioning the quadratic term first is that it has huge amount of implication in the area of finance. You have the logarithmic one. If we have considered those examples which was ln of p, that was just a theoretical example, but it has some implications later on also. We can have the third class as an exponential one and the fourth one as a power functions. So, these a, b, c's are whatever parameters. So, in general finance perspective, we would not be that much interested in finding out or estimate the parameters, but what we will be interested in is to find out the general characteristics of this utility function. Now, if you consider the quadratic utility function and do some simple calculations, you can find out the values of R, A, R bar and A bar, and they would be given by the values FUC as I was given in this bullet points, which would mean that if you have a quadratic utility function, it will have an increasing absolute risk aversion property and increasing relative risk aversion property. And I have done a very hypothetical example, taking the values of w on the first column, and then I have taken the values of quadratic utility function and then tried to find out using very simple Excel sheet, found out the value of AW, A bar, RW, R bar, and if you plot them, you see the values, the lower values are not that visible, but if you see the values of UW, it looks like a quadratic function, and the corresponding A bar, R bar would give you the characteristics of the utility function. Similarly, if you go to the logarithmic utility function, again the A bar and R bars are values are given by -1 by W square and 0, and again you can basically quantify the human being depending on whether he is risk aversion person or risk lover person or risk hater person, depending on the values or what are the characteristics of R bar and A bar. Again we have again the theoretical values given in the first column, the logarithmic of those in the second column, and based on that you can find out what is R bar and A bar, and then again I draw the curves and they give you the general characteristics of the logarithmic utility function. Similarly, when you go to the exponential one, the A is just a theoretical value which you have taken, and if you find out both the R bar is basically a constant and A bar, which basically is the absolute risk aversion's derivative with respect to W, is basically 0. Again you can basically classify a human being if he or she has that characteristics as a constant absolute risk aversion property and increasing relative risk aversion property. We take the values given as in this Excel sheet, which has been transmitted in this PPT slides. The first column again are W values, the second column are basically corresponding values of UW, considering that you have basically the exponential utility function, and then the corresponding values of A bar and the R bar are given. If you draw it, again you will get a characteristics and how the utility functions look like. Similarly, coming to the power utility functions, you have A bar and R bar value given, again R bar value is 0, and depending on the C value you will basically have A bar as positive or negative, because if you see the denominator, which is W square, would always be positive, so only C minus 1 would basically dictate what is the sign of the A bar value or A dash value. And and again you can characterize the human being or a decision maker who is taking the decision as decreasing absolute risk aversion property and a constant relative risk aversion property if that person has a power utility function as given. Again, considering the same trend, we consider W values, UW values, and corresponding the last column and next to next that, which is the A bar value, we basically have the A bar and the R bar for this theoretical example. And if you draw the utility function values, you have as it is given. So remember that when you are basically trying to draw them, I've used different color schemes for them. So if you see the pink one are obviously the utility function, then the corresponding yellow, light green, and the violet, so on and so forth. If you are able to do that, basically have the same coloring scheme, and you will be able to find out how the characteristics of the utility function looks like corresponding to UW, A bar W, and RW. Now, before I proceed about what is certainty equivalent, let me pause here and give you a brief utilization of the quadratic utility function, which I did mention that why it is important. Now, we all know, and we will consider the later on also, that in probability distribution, one of the very important distribution is the normal distribution. Normal distribution is basically a bell-shaped curve where the mean, median, mode are the same values. Now, it should be remembered for any distribution and any investment purposes, given amount of money which you are investing, you will basically get some return. Now, if you try to plot the return distribution, and if the utility function is quadratic, then it can be proved mathematically, then the return distribution would be normal, which in general sense means if the distributions are normal, then utilizing different properties of normal distributions give you fantastic results, and you are able to basically quantify risk to the best possible extent. And obviously, you get the diversification to the maximum possible extent, which we will be considering later on. But in general, returns are seen for different type of stocks, different type of portfolios, different type of options are never non-normal. So if it is non-normal, which means that the corresponding utility function based on which you will be trying to utilize different size situations are not quadratic. So which means that the utility function concept which we will consider initially would be of quadratic nature, and hence the returns as normal. And later on, as we go into the concept of different type of extreme value distributions, how they would basically change your utility functions, how they will basically change your returns would also come into the picture, such that trying to analyze the portfolios, trying to analyze different type of stocks, how to analyze different type of risk and return perspective would basically change as we proceed from the case of utility function being quadratic to the case where the utility functions are not quadratic. Continuing our utility discussions, utility function discussions, we did mention that what is the implication of quadratic utility function and why it is important. We will consider a few important concepts which may not be very apparent in the initial stage, but later on when we do the portfolio analysis from the quantitative finance point of view, it will be important. So, consider the very simple concept of certainty equivalent. Certainty equivalent in a very simple sense means that what is the overall certain value which you will get given a situation. So, if you consider a utility function given a UW with some utility function depending on whatever the probability distribution is for that utility function, we can find out the certain equivalent to be that value of C which will give you the same expected value. So, let us consider this with a very simple example. So, that how and we will consider that why this value of C is important. The value of C is important in a very general sense, considering that you have different type of portfolios where the outcomes are non-deterministic. So, when you are trying to analyze different type of portfolios, our main concern is to find out the average value of the portfolios as the ranking becomes very important for you, and you are able to rank the portfolios in such a way that you are able to take the decision which is best to your knowledge, considering whether you want to basically minimize your risk, whether you want to basically maximize your return, or whether you want to basically take a decision which is in between, depending on it is basically a compromise where you increase the expected value of the return to the maximum possible extent and try to basically decrease the risk to the minimum possible extent such that the compromise can be made. Now, how is this value of C is useful is that suppose that we have decision process with a set of outcomes, and given the set of outcomes you want to rank them, that is point number 1, and you want to also find out that what is the exact form of the utility function based on which you can basically analyze any decision. So, a human being basically is able to give you the outcomes, but he or she is basically not able to quantify the utility function based on which he or she is taking a decision. So, your main task would be, given the certainty equivalence, you basically can find and use different type of mathematical techniques such that you are able to find out what type of person he or she is, and then what type of utility function you will be able to analyze. So, consider this very simple situation. Suppose you face two options, that means there are two outcomes. Under option 1 you toss a coin, if a head comes you win 10 rupees, while if a tail appears you win 0. Under option 2 you get an amount of M. M is a very a value which is unknown to you. Now, your main concern is basically to find out the value of M, which is the certain equivalent. So, if you solve this problem, considering that there is a utility function which is quadratic in nature, which is given with the value of W minus 0.04 in W square. So, it can be a logarithmic utility function, it can be an exponential utility function, it can be power utility function, but for our case we are taking the simple case of the quadratic utility function. So, if you find the quadratic utility function, what your main concern is that given the value of M, so M is the input which you are giving, which is the value, and if you basically convert that M value into its utility, that utility function is given by M minus 0.04 into M square. So, consider that is the overall expected value of for that case of M, and also consider that when you have option 1, when you are considering option 1, you have basically the outcomes given as 10, and if your head comes, and if you have value of 0 if your tail comes. So, if you find out the value of this utility, what you will do is basically you multiply 10 into half plus 0 into half, and that will give you an expected value, and based on that expected value you will basically find out that at what value of M would you get the same value of the expected value which is for the non-deterministic case. So, if we basically are able to solve, it will be this 10 value, which when a head comes, considering is basically an unbiased coin, you will multiply 10 into half, and then you will basically multiply 0 into half if your tail comes. So, from these two situations you will get the expected value of the utility for the case which we will consider as E1, and for the next case, which is a certainty case, you already have a value of W. So, when we are considering the value of W, this will be replaced by M, and the corresponding utility would be given by this. Now remember one thing which I didn't mention, but considering that you have already understood it, that the value of 10 which you have is not the value which you will be utilizing in your calculation. This is basically the 10 value which is going in as an input, and the corresponding output is coming would be U10. So corresponding to 10 you will have the utility where this m value will be replaced by 10 minus 0.04 into 10 square. So that will give you the utility corresponding to 10, that will be multiplied by 0 as the first term, plus when you have a value of 0 which is the actual wealth, that when converted in the utility function obviously is 0, because 0 minus 0.04 into 0 square is also 0, that will be multiplied by half. So based on that you will be finding out the value of E1, and once you find out the value of E1, you have to basically equate it to on the right hand side. On the left hand side you already have a utility based on the value of m. Now remember that certain equivalent basically means a coin which is for which the probability the outcomes are deterministic, in the sense the probability is 1. So once you multiply the utility which is here multiplied by the probability is 1, then the value of the certainty equivalent which you find out is basically 3.49, which means that given two situations, in one case where you input 3.49 and you utilize the utility function as given here, probability is 1, and on the other case when you have basically two arms where 10 is the input, corresponding to that you find out another utility function, 0 is the input, based on that you find out his utility function, multiply each of them by half and half corresponding to the case if it is an unbiased coin. When you equate that you find out the utility certainty equivalent. Before we go to the next slide, it should be remembered that the value of C, which is the certainty equivalent, will change depending on what your utility function is. So if I change the utility function, obviously you will get different values of C. So one should remember that if a human being has a quadratic equality function, or if human being has, say for example, the k or the logarithmic utility function, or if the human being has basically this exponential utility function. So depending on what utility you are using, the value of C would change depending on the situation. So the above example illustrates that when you will basically would be indifferent between option 1 and option 2, and based on you to find out the value of C, which you have already found out is certain equivalent. Now if you face a different situation as I mentioned, and if you change the value of and you get a different option 2 where you get a value of 5, so based on that if you use the same utility function which is the quadratic one, you will get a value of 4, which means that for a value of input of 5, you will get an expected value of that certain equivalent coming out to be 4. Here certainty I am using for the case that the amount of input value is 5. Now this when you consider with or try to basically compare with the value of 3.49, obviously it mean that your expected value for this decision where you are inputting 5 has got higher returns or expected value, hence you will basically take the one which is given by 4. Now for the venture capital problem which you have already considered, if you consider the certain equivalent value comes out to be 609. Only remember that in this case the venture capital example, the utility function which you are using is not the quadratic one, it would be corresponding to the case which you have already considered in the venture capital example one. So a risk averse person will select an equivalent certainty rather than the gamble, because he or she obviously doesn't want to take any risk. A risk neutral person is indifferent between them, and a risk seeker person would basically select the one where the certain equivalent is not that important, because he or she basically analyzes a situation where the outcome is more based on the probabilistic one, and he or she basically thinking of that outcome when the value actually is much higher. Now we will consider very simply, without going to the theoretical details, that how the expected value and the certain equivalent can be matched in order to basically make a decision where you are basically indifferent between them and try to find out those values. So consider this very simple example, a theoretical one, where you have two values given as A and B. Now what you want to find out is basically the certainty equivalent. So if you consider a very simple quadratic utility function or whatever it is, so what you will do is that as you keep changing the values on two arms, so consider you have this example, both the probabilities for our case consider they are half and half, and what we are considering is that you are basically inputting a value of W, and based on that this expected value you will basically find out a utility function of UW for some value which you are importing and a uw for the value which is importing. So, obviously, these values are different. Now, consider for the time being these probabilities are P1 and Q1. So, as P1 and Q1 changes, obviously, the value of the utility also changes. So, what you are trying, and your actual task is to find out the expected value of this equated to a value of expected value of C, which is the certain equivalent and for this case, remember this UC is being multiplied by 1. This 1 is basically the probability is 1. So, as you keep changing the values of P1 and P2, and as you keep changing the values of utility functions, you will find out different expected values. So, these A's and B's are expected values. So, as you keep changing them, you will try to find out a convex combination of A and B such that the overall value or the expected value of A and B in the long run should be exactly equal to C, such that the certain equivalent for that decision for that human being or for the decision maker can be found out. We will consider very simple examples later on as we do the problems in portfolio analysis. Now, A and B are wealth values, consider for our time being the values and also for the case of our analysis we consider the UW is a linear function which is W.